Go ahead.
Actually, can I use this as a brief time to go back to the second, the model that you had using rates and flows of this system? Because there's a third piece of information on there, and I'm curious how you all think about that, and that's the goal. Because I can imagine as people are going back to their own environments and translating their environments and thinking about the rates and the levels in their environments, that they're also thinking a lot about the goals of those environments. So Jay, going back to the analogy that you drew for a company and the balance sheet and the income statement, I could imagine that there may be two very different companies whose balance sheets and income statements look very similar, but their strategies are very different. So the way in which you interpret those balance sheets and income statements become very different. So I'm curious, is that a third piece of the equation of
I think we ought to say a word about what's meant by a goal in this diagram.
Okay.
It is the goal for a very local, specific decision maker. What is that person trying to do at that particular point? It's different from strategy. It's different from the abstract overall goals of the corporation. The system dynamics process causes you to look at what people are doing and what are the people actually making decisions that result in action. What are they trying to do at the decision-making point? Someone is controlling inventory. Somebody is hiring people against some goal of matching the necessary production rate. Someone is borrowing money because they need it in the bank account. There's a goal at every point where something is happening. And the overall goals of the corporation have to be interpreted, if they can be interpreted, down to the working level. So a goal at this decision-making point, first of all, can be a variable. It may change with time. And in a more complicated system, it will itself be a dynamic variable that depends on the history of what has happened, depends on the pressures that people are under, may change from time to time. But in the bigger picture, I think to the extent that these overall social system goals that you speak of, to the extent they have any influence, and often I think they don't, to the extent that they have any influence, they have to be interpreted into their effect on the individual points where actions are taken. But my main stress here is that you're looking, when you talk about goals, when you talk about information, when you talk about action, you're talking about real action, something that is being done, and what is controlling it, that activity at a local point.
So more specifically, just to make sure that I understand, a goal here in this system would be, in the system of water and filling up a cup, would be the person is intending to fill the cup all the way up with water.
Yes, up to some level. We should elaborate this idea of rates, controls, decision-making, and goals. We use this even for physical systems. What is the goal of a clock pendulum? It is to seek the vertical. We use the idea of policies or rates in the absence of any word that I know of that sweeps across all fields. We use the idea of a rate equation or policy to describe how action is controlled. And so I rather freely, and probably to some people's consternation, will talk about the policies governing a clock pendulum. And this is simply because there is no word that transcends all fields that seem to carry the idea of how the levels in the system control the rates. There's another generality in this diagram that I think I did not mention, and that is that rates of flow are controlled only by levels, never by other rates, and levels are changed only by rates of flow, never directly by other levels. Other levels may influence in the sense that some other level may control this rate, which controls this level. But it is some specifically nameable rate of flow that's changing the level. And this is not just physical variables. These can be, the level can be trust. The way in which your sense of trust of someone changes based on what they have done to increase the trust you have or what they have done to reduce it. So we open this idea up to what are ordinarily thought of as non-quantifiable variables, and yet I would say any variable you can talk about in a meaningful way can be quantified. And so we move right into confidence, trust, attitudes, as well as the physical variables. And some of the more interesting corporate models that I've dealt with probably had less than 10% of their variables being things like numbers of people and machine tools and inventories, and 90% having to do with the attitudes, the information flows, the interpretations that in the ordinary world are not quantified, but which when you build a model, you do explicitly quantify them and you adopt a scale for them. And when you do this, you then look at each operating point for this idea of what is the goal or how are the decisions being made.
I guess I would like to continue discussion about how to precisely or with some kind of precision model these soft variables or policies.
Well, you've used the word, how do you deal with the soft variables precisely? Now, precise, I think, by definition is that you have stated something explicitly, which is very different from accuracy. Does it actually match the real world? And in a system dynamics model, you are precise in the sense that you make an explicit statement about what you mean by one of the soft variables, and you make explicit statements about what you believe cause those system levels like integrity to change. Now the question comes, how accurately must one define these processes to be useful? And I think what I see in a lot of work, especially in academia, they stay away from variables for which they cannot get numerical measures because there is, I think, the lack of courage to deal with the things that people know are present. And if you can talk about integrity, you can model it. And I would say take a matter of corporations bidding on government contracts. If you were discussing the extent to which maybe they intentionally underbid in order to get the contract, knowing that they can make up the difference in extra charges later. If you were to take some issue of that sort and name 10 corporations for people that know more or less about them, I submit that they would rank them in approximately the same order in terms of integrity. Not identically the same order, but the high integrity ones would come off at the high end of most people's estimates. The low integrity ones would generally be distinguished. And at this point, on a scale of 0 to 10, you have the ability to say, well, company A is what I mean by 8, and company B is what I mean by 3. And now you have a scale. And that process is only an intellectual process of defining what you think, what you observe. And when I say you, I mean a group of people who may discuss this issue. The important thing is what do you do with that scale once you get it? What do you do? How does an integrity of 8 cause decisions to be made differently from an integrity of 3? And then you get into the matter of goals and rates of change in the organization. But again, you can look at real life organizations and see these differences.
I think, too, returning slightly to our initial question about what is system dynamics, I think that exact example communicates a very important point, which is that if you take these companies and put them on this scale, this is not an arbitrary academic exercise. I mean, we're not doing it for our health. The reason you do that is because that is a decision that someone's going to make anyway. system dynamics models are typically focused on real problems that people care about. And the fact is, in that particular case, that trustworthiness is a variable that people are going to factor into their decision making. And they're going to be making that rank ordering of the companies implicitly whether a system dynamics person helps them build a model or not. And so it's that fact that somebody cares about it that then moves this into the world of something useful, not just the sort of random exercise of applying useless values. And I think one of the defining characteristics is that what guides all the work, I think, that happens in this field is real problems that people are really focused on. And if long as someone is going to make that decision anyway, use that information anyway, then it becomes something worthy of modeling. And I think what you said earlier is that if you can talk about it, you can model it. And I do think that that is an assumption that is fairly unique to this methodology. I think, at least in the rest of academia, people aren't similarly courageous, to use your adjective, to take on those challenges.
You see, there is criticism of the system dynamics field on the basis that we deal with these kinds of concepts and variables that are normally not numerically measured. And my feeling is that to leave them out, as much of academic modeling does, is probably the worst of all possible assumptions. That some sort of set of assumptions growing out of observing real life, talking to people, is much closer than saying, in effect, that integrity has no effect on anyone. And therefore, we would put in these soft variables in situations where we think they are important to the problem at hand, even though there will be some variability as to how people would set the scales. Nevertheless, I assert that generally there will be, among different observers, a substantial similarity of how they will judge what integrity means and what effect that it has.